the law of sines and cosine problems. I don't have anything new to add per se to any techniques or material you have learned in this section, but I want to point out a few things that I am looking for you to do, be able to do while you're doing this material that will also aim you well for going on into calculus. So I want to take a look at this particular problem that is in section 6.6. It's section 6.6 problem 14. It's a book example on page 471. It is worked in the book, and it is also on the old practice tests, and I've worked it in the answer key for the old practice tests. But I want to work through this problem again and just kind of give a few pointers about things I'm looking for you to be able to do. So this is the triangle that's described, and we're asked to solve for information here. So we need to be able to draw it. So big angles are big letters, sides are little letters. The side with a little letter has to be opposite the angle. So this is, angle A is 45 degrees, side A is 7 root 2, and side B is 7. So we want to solve for this triangle. So we want to use the law of cosines to do this because we are given a side angle pair. We're told little a and big A. So I could set up the law of sines to this. So we could do sine of 45 degrees over 7 root 2 equals, and we need to solve for big B. So we could do sine of big B over 7. Now, I'm not looking, and you hopefully gathered this from the first test and some of my other videos, I'm not looking for you to just blindly be able to plug everything into the calculator. If you can symbolically manipulate something without having to use your calculator and decimals, I'm looking for you to do that to get full credit. So here, you should be able to recognize that the sine of 45 degrees is root 2 over 2. So I could replace that like this, and then simplify this. Turn the bottom of our compound fraction into a fraction by slapping 1 in the denominator. And then now I need to do a little fraction manipulation. Square root of 2 over 2 times 1 over 7 root 2. That's how you multiply fractions, is you flip the denominator and multiply. These cancel and we get 1 over 14. So I get 1 over 14 equals sine B over 7. Solve for sine B. We get 7 over 14 equals sine B. Take the sine inverse of both sides. So B equals sine inverse of 1/2. Again, this is something that you should recognize as a 30-degree angle by having the unit circle memorized. However, you've also probably already encountered some law of sines problems where you might have more than one answer. There's another angle that has a y value of 1/2, and that's 180 minus this 30 degrees. So here, in this section, unlike the previous chapter, we're not looking for the inverse functions to be strictly functions. We'll accept multiple answers. So an angle of 150 is also a possible answer, except this can't work because 150 plus our 45 degrees is not a legal value for the number of degrees in a triangle. That's over 180. So only 30 degrees works. And I didn't need to do any calculator work at all to do this. So bear that in mind when you're going through and doing these problems. I also want to state one other thing that is wise to do while doing these kinds of laws of sines and cosine problems. So once I solved for angle B, and I know that B is 30 degrees, I have several ways I could solve for C, big C. I could do sine of A over A equals sine of big C over little c. And or I could set this up as sine of 30 degrees over 7 equals sine of c over little c. And I know that C is going to be 105 degrees because I could add 30 plus 45 to get 75 and subtract that from 180. So I know that this is going to be um, 105 degrees. So I could substitute that in here for my angle C. So I could solve now for little c using either of these. What I want to point out is what you should do, you should always do, is use the equation that uses the least amount of derived information. Um, what I mean by that is I don't want to use an answer I've already calculated, right? And that's because there's rounding error. In this particular example, this is not a phenomenal example of this case because there was very little error because I didn't need to do any decimal work because this was all exact and symbolic, which was that's why I want you to do it with symbolically and exactly without using decimals. But if I used this second setup here to derive my little c, and I used a value that I derived for this angle, well, there's going to be rounding error in that typically. So that means there's going to be even more rounding error when I calculate c. So you always want to use the setup that will involve the least amount of rounding error, which typically will involve using an equation that has the information that was given in the problem. So side A and angle A was given. So I want to use the setup that involves those because those are precise. There was no rounding in that information because it was stated in the problem. Okay, guys, thank you very much for your time. Let me know if you have any questions. My door is always open, and good luck on the tests, and I'll see you guys later. Bye bye.